Ever feel like science is moving too slow? Like we're missing breakthroughs because we're stuck in old ways of thinking?
Totally. What if AI could be more than just a tool, but an actual partner in discovery?
That's exactly what we're diving into today. We're unpacking a fascinating paper about an AI co-scientist. Think of it as an AI teammate designed to help researchers come up with new ideas and experiments.
So what's on the agenda? What are we going to explore?
First, we'll break down how this AI co-scientist actually works. We're talking about a multi-agent system, which is basically a team of AI brains working together. Then we'll see how it uses a generate, debate, and evolve approach to come up with better and better hypotheses. It's like a digital brainstorming session on steroids.
Sounds intense. What kind of problems is it tackling?
We'll look at real-world examples like finding new uses for existing drugs, discovering new targets for treatment, and even understanding how bacteria evolve. Plus, we'll discuss how this AI is designed to work with scientists, not replace them. Finally, we'll touch on the ethical considerations and what the future might hold. Buckle up, it's going to be a wild ride. All right, let's dive into this paper about the AI co-scientist. It's a pretty ambitious project aiming to augment scientific discovery, right?
Exactly. It's not just about automating tasks, but actually collaborating with scientists to generate novel hypotheses and design experiments. They're using a multi-agent system built on Gemini 2.0.
Gemini 2.0, that's Google's large language model, right? So it's basically using AI to brainstorm and reason through scientific problems?
Yep, but it's more structured than just a chatbot. They've designed it with a generate, debate, and evolve approach, mimicking the scientific method itself.
Okay, walk me through the architecture. What are these agents doing?
So you've got specialized agents like generation, which comes up with initial hypotheses, reflection, which acts like a peer reviewer, ranking, which uses a tournament system to compare hypotheses, and evolution, which refines the top ideas.
A tournament system? That sounds interesting. How does that work?
They use an ELO-based tournament, similar to what's used in chess rankings. Hypotheses are compared pairwise, and the ranking agent uses simulated scientific debates to evaluate them.
So the AI is debating with itself. What about the other agents?
There's also a proximity agent that groups similar ideas together, and a meta-review agent that synthesizes insights from all the reviews to improve the system's performance over time.
That meta-review agent sounds crucial for the self-improving loop they're talking about. It's like the AI is learning from its own mistakes.
Precisely. And it's all underpinned by a significant scaling of test-time compute, meaning they allocate more computational resources during the reasoning process to improve the quality of the outputs.
Test-time compute. So it's not just relying on pre-trained knowledge, but actively thinking harder when it's trying to solve a problem. Makes sense?
Exactly. They're validating this system in 3 biomedical areas: drug repurposing, novel target discovery, and explaining antimicrobial resistance.
Drug repurposing is finding new uses for existing drugs, right? How's the AI doing with that?
They've proposed candidates for acute myeloid leukemia, AML, that show tumor inhibition in vitro at clinically applicable concentrations. Pretty promising.
Wow, that's a big deal. What about novel target discovery?
For liver fibrosis, the AI suggested new epigenetic targets that were validated by antifibrotic activity and liver cell regeneration in human hepatic organoids.
Okay, so it's not just generating ideas, but also finding targets that actually work in lab settings. And the antimicrobial resistance piece?
The AI co-scientist recapitulated unpublished experimental results by independently discovering a novel gene transfer mechanism in bacterial evolution.
That's incredible. It's like having a virtual research partner that can come up with hypotheses and validate them in silico. But how do they ensure the AI is generating novel ideas and not just regurgitating existing knowledge?
That's where the reflection agent comes in. It rigorously checks the novelty of the generated hypotheses against existing literature. Plus, the tournament system favors ideas that are both novel and testable.
So it's not just about being new, but also about being something you can actually do something with. What about the expert in the loop aspect? How do scientists interact with this system?
Scientists can specify their research goals in natural language, provide feedback on generated hypotheses, and even contribute their own ideas to the tournament. It's designed to be a collaborative process.
That's key. It's not about replacing scientists, but empowering them with a powerful tool. What are some of the limitations they mention?
They acknowledge limitations with literature search, potentially missing critical prior works. Also, the system doesn't have access to negative results data, which can be crucial for guiding research.
Right, knowing what doesn't work is just as important as knowing what does. What about safety and ethical considerations?
They address dual-use risks, the potential for harmful applications, and the need for ethical guidelines. They've implemented safety mechanisms like automated safety reviews of research goals and hypotheses.
That's good to hear. It's crucial to think about the potential downsides of such a powerful technology. Overall, this AI co-scientist sounds like a game changer for scientific discovery.
It definitely has the potential to accelerate research and democratize access to scientific information. It'll be interesting to see how this technology evolves and how it impacts the scientific community in the years to come.
Well, that was quite a journey into the world of AI-driven scientific discovery. It's fascinating to think about how these systems can help us push the boundaries of knowledge.
Absolutely. It's not just about automating tasks, but about truly augmenting human intellect. The idea of an AI rigorously debating hypotheses, refining them, and even suggesting entirely new avenues of research, it's pretty mind-blowing.
And the examples we discussed, from drug repurposing to understanding antimicrobial resistance, really highlighted the potential impact. Imagine accelerating the pace of discovery in fields like medicine and materials science.
It also brings up some important questions about how we collaborate with AI, how we ensure novelty, and of course the ethical considerations. It's clear that responsible development and deployment are paramount.
Definitely. It's a powerful tool, and like any tool, it needs to be wielded carefully, but the potential benefits are enormous. It feels like we're on the cusp of a new era of scientific exploration with AI as a key partner.
Here's to hoping that this kind of technology helps us tackle some of the biggest challenges facing humanity. Thanks for joining us on this deep dive. We'll be back soon with more explorations into the ever-evolving world of AI.